The equation of a line can be presented in one of several forms. General form is ax plus by plus c equals 0, where a, b, and c are constant values and x and y represent the variables. Point slope form is y minus y1 equals m times x minus x1, where m represents the slope and x1 and y1 represent a particular point on the line, and again x without the subscript and y without the subscript are variables. And finally, slope-intercept form is solved for y, so it takes the form y equals mx plus b. There are two special cases that deserve separate attention. A horizontal line has the same y coordinate at every point, and so we can express it simply as y equals some number. This is actually a slope-intercept representation where the slope equals 0. Vertical lines, in a sort of similar way, are also special. Vertical lines have the same x coordinate all the time, and so we can express them in an equation as x equals some constant number. And now this is a little bit unique. It's kind of like a general form equation in a way. But what's important to remember is that vertical lines have an undefined slope. So there is no number that we can put in to a formula to represent the slope for a vertical line. And so we can't use slope-intercept form to describe a vertical line. So let's look at a couple examples. In this first example, I'd like to determine the slope and y-intercept of the line given by the equation 2x plus 3y minus 12 equals 0. So you'll notice this is in general form, and in order to find the slope and the y-intercept, it would be nice to have the line in slope-intercept form, because in that case m represents the slope and b represents the y-intercept. So we can get it into that form if we solve for y. So I'm going to add 12 to both sides and subtract 2x, and then divide by 3. And I want to make sure I divide all the terms by 3. So there are 3 separate terms. We divide 3y by 3 to get rid of the coefficient, but then I also need to divide the x term by 3 and the 12 by 3. And so we end up with y equals negative 2/3 x plus 4, which tells us that the slope is m equals negative 2/3, and the y-intercept is 0, 4. As a second example, let's try to write the point slope form for an equation that passes through the point negative 6, 8 and has a slope of 5. In this case, what I'd like to use is the point slope form, because I'm given a point and a slope of the line. 5 is going to be our value for m, and negative 6, 8 is going to be the coordinates of the point x1, y1. And so if I fill in those values in our formula, I get y minus 8 equals 5 times x minus negative 6. So we have y minus 8 equals 5 times x plus 6. And if we solve for y, we'll get our solution in the slope-intercept form that we're looking for. So we can distribute y minus 8 equals 5x plus 30. If I add 8 to both sides, we can see that the slope-intercept form for this line is going to be y equals 5x plus 38. It's always a great idea to have ways to check our work, and one way to check is to just double check this point. If I plug in negative 6 for x, do I get the right value? So if x is negative 6, I get 5 times negative 6 plus 38. but that's going to be negative 30 plus 38, and so yeah, I get a y value of 8. So that works. And so since I can clearly see that the slope is 5, and that when I plug in negative 6 for x, I end up with 8 for y, I have a pretty good feeling that this is a correct formula. I encourage you to take a moment to solve the following problem. Find an equation for the line that passes through the following 2 points, negative 2, 4, and 7, 1. I would recommend starting by trying to fill in the point slope formula like we did in the example just now. But what you need to figure out first is what is the slope. I hope you enjoyed the video. Thanks for watching.